All right, I'm picking up where I left off on the problem 8-20. 8-20 is, of course, the problem with the bicycle wheel, and a very weird problem with the way that it was written, having it be 70.75 seconds. It completes the whole cycle, so we actually had to half the cycle to figure out high points and low points to use. And then even figuring out those half points, we had to go one smaller to figure out the first high point, because I need that first high point and low point, first high point, then low point to create the cosine function. I then went on to do the period. The whole thing happens in 0.75 or 3/4. The amplitude was 20 because the midline was found to be 35. 20 more than 35, that's 55. 20 less than 35, that's 15, so that tells me the amplitude is 20. The horizontal shift is the distance to the right, or the shifted distance of the first high point, especially for cosine, or I should say only for cosine, and so the horizontal shift is the 0.125, and then the vertical shift is always the midline there. And so I get my final equation here, and then we'll graph it, and we'll move on. We have h of t is equal to the amplitude first, which is 20 cosine of my b value, and the b value is 2 pi divided by my period, which is 3/4, and we'll see who can kind of figure out what that is if you reduced it down. Keep, change, flip happening there. That's t minus the horizontal shift of 0.125 plus the vertical shift of 35 there. For you keep, change, flip fans, if you keep, change, flip this, that will end up being 8 pi over 4, because dividing by 3/4 is the same thing as multiplying by 4/3. And when you do 2 pi, we can say it's like 2 pi over 1 multiplied by 4/3. That multiply the top, that's 8 pi. Multiply the bottom, that's just 3. Okay. And so that's really going to be 8 pi over 3 on my equation on Desmos, but everything else should look the same, and we'll then answer the questions B and C and move on. And let's go to the Desmos now. So we see 20 cosine of, like I said, 8 pi over 3, t minus 0.125 plus the vertical shift of 35. We graph it, looks terrible. See if we can zoom in a little bit and by the y-axis, which is kind of the important piece. No matter what, it's not very good. Kind of just hard to see here, but that's okay, because to answer the first question, we need to figure out what was the height of the reflector at 5.2 seconds. Well, the height of the reflector at 5.2 seconds, that's me plugging in 5.2, and the height was at 37.09, and I believe this one is in centimeters. Let's check again. Yep, centimeters. So 37.09 centimeters is what it was at 5.2 seconds. I'll go back and plug this in for t so we get the equation again. And then it says, when is the first time that the reflector is at 53 centimeters above the ground? So that's what we've been doing, is when we create this, and we set y equal to 53, so we get a horizontal line there. We've got to find that line. It's up there. And I'm going to zoom in at the first place I can find that would happen. And it looks like the first time it happens is right there at 0.712 seconds is the first time that happens. It's the first time we hit 53 centimeters there. Very interesting. All right, let's go to the next one. And this is going to be the only one, the last one I'll do. And then I want you to go all the way through 24. Don't worry about, I don't know why 35, I think it's supposed to be 25. I want you to go through all the way through 24. I know that I'm leaving you with some. But try your best with these. I think it's a good one, using the videos, and if you have any questions, you can always email me. I can make a video guide specific to the question that you have, and I'd be more than happy to make that video for whoever asked the question, post it in Google Classroom or whatever. So reach out if you need extra help. I know I'm not there. I know that makes it difficult, but I really do want you to keep trying and hopefully understanding this concept here. And then, again, things will be recapped when we get back, or when I get back, excuse me, on Monday. So here in 821, the temperature during the day in Math America can be modeled by the sinusoidal function, sine or cosine. At 4 a.m., the temperature is at its low, and at 4 p.m., the temperature is at its high. write an equation that models t in hours after midnight. So like t equals 0 would be midnight. And so like t equals 4, that would be 4 a.m. And that's what I'm going to use. And so at 4, I'm at my low point, and that is at 65 degrees. And you can think, well, what's 4 p.m.? And how many hours after midnight is 4 p.m.? Well, 12 from midnight to noon, that's 12 hours. 4 more hours puts me at 16. And then I'm at my high point, which is 103. And I can't really work backwards to find a high point to low point here. And so this is one where it's pretty much required that we use sine. And remember, not a whole lot is going to change with using sine other than the horizontal shift. And the horizontal shift is really the only thing that's going to change, is that we're going to use the middle point between the x values 4 and 16. We'll see that though. Let's start with the period of the function. And I like to change colors here today. The period of the function is going to be, well, it takes 12 hours for the first one to happen. It's going to take an additional 12 hours to repeat. So that's in total for the whole thing to happen, 24 hours, full day to repeat. The amplitude of the function, let's find the midline of it. I think this one is pretty nice. 65 plus 103, that should put me at 168. 168 divided by 2 puts me at 84. Okay, so that's the midline, or actually going to be my vertical shift. And then I'm thinking about that distance. So like, what is it to go from 65 to 84? That's, I believe, 19. Yep, 19. And then, so like 19 less than 84, 65. 19 more than 84, that's 103. So that tells me my amplitude is 19. My horizontal shift, because I'm going to use the sine function, because I can't really go back any further without going kind of negative time, that horizontal shift is going to be a sine function, which is the middle point between 4 and 16, and that is 10. Yeah, and you could do that by similar to how I figured out my midline is 4 plus 16 is 20. 20 divided by 2 is 10. And then the vertical shift is, as always, my midline, which is 84. And then I have enough to set up my sine function here. The sine function is going to start with the amplitude. So this is h of t equals 19. It's the amplitude. Sine of 2 pi divided by my period of 24. T minus the horizontal shift of 10 plus the vertical shift of 84. In terms of my handwriting, that doesn't look too bad, especially the sign there. Okay, and again, this can be reduced down. Maybe you can see this. The 2 and the 24 will reduce down, so that's just going to be pi over 12. Everything else looks good, and we'll graph it on Desmos, answer the questions B and C, and then that's going to be it for this one, and I'm going to leave the rest of them, 22, 23, 24, up to you with how much time that you have left. You might have noticed before I go to Desmos, there is no homework. So continue on with some of these problems if you feel you need extra practice. I'll talk more about some of these problems when I get back to kind of keep going and elaborate this a little bit better with me in person. But, you know, really practice this. I think it's a good concept and one that if we understand this, we're at a good level of pre-calculus. Okay. Let's put that in Desmos, or it's already in Desmos. Let me put this one away. I have that there, 19 sine. Remember I said 2 pi over 24 is the same thing as pi over 12. T minus 10 plus 84. We can graph that, zoom out, so I'm guessing it's going to be higher up because it's plus 84. There it is. And we can start answering some questions. The first question asking us, what is the temperature at 11 a.m.? 11 is 11 hours after midnight, 11 a.m. is, and so that's a T equal to 11. So I'm just going to plug in 11 for T, similar to a problem we did yesterday. And that tells me that the temperature at 11 a.m. is 88.91, or sorry, if I round it, 88.92 degrees at 11 a.m. Okay, very cool. Go back to the T value. And of course, they're going to ask us, when is the first time in the day when the temperature is going to reach 98 degrees? And so I'm going to set as I've done before, y equal to 98. And 98, the first time that happens in the day is at 13.16, so that's a little bit after 1 p.m. It would hit 98 degrees. Now, temperature doesn't always work that way, that it's going to be sinusoidal. Like each day it's going to be the lowest and the highs being the same. But kind of cool that we can represent this and do this problem in the way that we did. Now, again, the parameters are specific so that it works, but nonetheless, interesting that we can say, hey, the first time it's going to reach that temperature that day is at 1 o'clock. A little after. All right, that's it. And like I said, 22, 23, 24, I'm going to leave those up to you to try to work on, whether it's with your group, individually, homework, in class, with the time that you have left. If you have any questions, again, please email me. If you have any feedback on like your videos were not that helpful, your videos were helpful, anything, just email me. I'll be around my computer and you can ask. Okay. Have a good rest of your day, and we'll move on to 8.813 tomorrow.